Hello, this is my teaching video about relations and functions in math. So I'm going to start off with a basic overview of how relations and functions work. And then I'm going to show a few examples. Alright, so a relation is pretty much anything. And a really good way of representing relations and functions is using something called mapping. So with mapping, you want to take your domain and your range. So let's say the three numbers that we have are 5, 7, and -3. And over here we have 1, 0, and 4. So a relation, as I said, can have any property. So let's say we have something like this. A repeating y value where these two numbers both go to the same y value, while this one does not repeat. And let's say this value, this x value, also goes over here. That's a repeating x value. So we have -3 occurring twice in the x as an x value, and 1 occurring twice as a y value. So next we have functions. So a function cannot have a repeating x value, and it has to pass the vertical line test on a graph. So in mapping, we have our domain and our range. And let's have 1, 2, and 3. And let's have -2, 0, and 2. So let's say when x is 1, y is -2. We don't want x to be repeating, so we wouldn't, or y to be repeating, so we wouldn't have 2 being the same here, or maybe 1 going to 0. That's a repeating x value. So to have a domain, a function, we have to have no repeating x values. So 1 is 2. When x is 2, y is 0, and when x is 3, y is 2. So this is an example of a function, while this is an example of not a function because it has repeating x values and repeating y values, while this map right here, it doesn't have any repeating values. And now we have a little side lesson, one-to-one functions. So what a one-to-one function is no repeating x or y values. So a normal function can have repeating y values, but no repeating x values. But a one-to-one function can't have repeating x values or repeating y values, and it has to pass both the vertical line test and the horizontal line test on a graph. So for normal functions, let's say we have a normal graph like this. And here's our vertex, our middle. So we need to have a vertical line going right through here and not passing through any of these points or on the sides to pass the vertical line test. But to pass the horizontal line test, we have to have a line coming in horizontally, and it also can't pass any of these points. So this would also be a one-to-one function on a map because it doesn't have repeating x or y values. But if we have, let's make 2 more over here. And let's have 1, 2, 1, 2, 3, 4, 5, 6, and just 0. So down here, let's say 1 is also 0, but 2 is also 0. So this would just be a function because it doesn't have any repeating x values, but it does have repeating y values. It's also a relation because any equation could be a relation. However, it is not a one-to-one function because it has repeating y values, and you can't have repeating x or y values. And if we're over here, we have 1 repeating, 2, and then 3. We have both repeating x and y values, which we already mentioned over here is only a relation, and it can't be a function or a one-to-one function. So I am going to give some examples now. Let's erase all this. And I would like you to pause the video for each example, and I would like you to tell me if it's a relation, function, and one-to-one function. So if it's a, write down those 3 words and put a check mark if it is any of those, and put an X mark if it isn't any of them. And we're going to use maps, and then I'll go on to graphs after. So first example, with maps, we have our domain and our range. So R for relation, F for function, and let's have O for one-to-one function. Let's have 1, 4, and 6. And over here, let's have 1, 2, 3, and 5. So let's say when 1 is 1, when x is 1, y is 1. When x is 1, y is also 2. When x is 4, y is 3. And when x is 6, y is 5. Now I would like you to pause the video and give a check or an X for what you think it is. Alright, so now that we've completed this problem, let's see which of each of these categories this problem falls into. So it's a relation because, as I already mentioned, everything can be a relation. Repeating x, repeating y, not passing horizontal or vertical line tests, you name it. So next, we have function. Is it a function? No, because it has a repeating x value. 1 is 1, but 1 is also, when x is 1, it is also 2. So that means that it's not a function. And lastly, one-to-one functions. It has a repeating x value, and as I went over, one-to-one functions can't have repeating x or y values, so it's not a one-to-one function either. Okay, here's problem 2. This one's going to be another map. And this time the values are going to be 4, 7, 12, 1, 2, 0, and 5. So when x is 4, y is 1. When x is 7, y is 5. And when x is 12, y is 2, and y is 0. So pause the video and let's see which categories this one falls into. Alright, good job. So 4, when x is 4, y is 1. That's good. So, as I already said, it has to be a relation. When x is 7, y is 5. That's also good. We haven't had any repeating x or y values yet. And when x is 12, y is 2 and 0. There we have a repeating x value. So unfortunately it's the same as the problem before. It's neither a function or a one-to-one function, just a relation. Good job. That's my tutorial on mapping, and next we're going to look at graphs. Okay, and we're back. So next we're going to look at some graphs. Here is the first problem. And here is our graph. And I want you to pause the video and tell me if it's a relation, function, or one-to-one function. Good job. Here we are back, and let's see. It has to be a relation. And for function, we have to see if it passes the vertical line test. So let's go straight down the middle, and oh, it already hit something, and it also hit something here. This proves that it is not a function. And if it's not a function, it also can't be a one-to-one function, because although it passes the horizontal line test, it also doesn't pass the vertical line test, and a one-to-one function has to pass both a vertical and a horizontal line test. Next, let's look at the second example. Alright, I want you to pause the video and tell me if it's a relation, function, or one-to-one function. Alright, let's see. Well, it has to be a relation, as we've already gone over, and let's see if it passes the vertical line test. Oh, it looks like it does pass the vertical line test, so this is also a function. Now, let's see if it also passes the horizontal line test. It seems that it does not pass the horizontal line test, so that means this equation, or this graph, is a relation, a function, but not a one-to-one function. Let's move on to the final example. Alright, now I want you to pause the video and tell me if this is a relation, function, or one-to-one function. Alright, so let's see, does it pass the vertical line test? It does pass the vertical line test. And does it pass the horizontal line test? Yes, it also passes the horizontal line test, meaning that this graph is a relation, function, and a one-to-one function. Good job. Now we're going to go a little bit more in depth about these topics. Alright, now let's look at an equation. So, when you want to find if an equation is a relation function or one-to-one function, you want to see or test different values in the variable. So, let's say f of x is equal to x minus 2 squared plus 3. So, if you would like, you can make a map or a table of values with your domain and your range. So, let's say x equals 1. So, 1 minus 2 squared plus 3. So, 1 minus 2 is negative 1, squared is 1, plus 3. So, 1 plus 3 equals 4. So, when x is 1, y equals 4. Alright, so let's say x was 2 and then 3. So 2 minus 2 squared plus 3. So 2 minus 2 is 0, and 0 squared is 0 plus 3 is 3. So in this instance, when x is rising in value, y is decreasing in value. But so far, we haven't had a single repeating x or y value. Lastly, let's do 3. 3 minus 2 squared plus 3. So, 3 minus 2 is 1, and 1 squared is 1. So 1 plus 3 equals 4. So when x is 3, y went back up to 4. So we can actually cross this out. And as you can see, we have a repeating y value. which makes this equation a relation function, but not a one-to-one function, because it has a repeating y value. Alright, so for the next example, we're going to have x equals y squared plus 3. So here, let's isolate y squared, so subtract 3. So we have y squared equals x minus 3. But we don't like this here, so we're going to square root this. So we have y equals. However, we just introduced a square root, so we have to add a plus or minus sign in front of it. Now I want you to remember that. Make a little side note that we need to add a plus and a minus sign when introducing a square root. And I'm sorry I didn't write the whole thing, it's just hard to on this whiteboard. So now what we have here are two different, you could say, things or equations. One's positive, one's negative. So we have our trusty tool Desmos here. Y equals, how do I get the keyboard? There it is. The square root of x minus 3. And here we have our graph. So it starts here and it gradually keeps going up and up infinitely. And it never goes below 0. So recognizing domain and range, x is greater than or equal to 3 and y is greater than or equal to 0. And then over here we have y equals negative square root x minus 3. Now that's just the inverse of this equation, so it's exactly the same as this, just flipped over the x-axis. So let's see. It does pass the horizontal line test, going right through here, but it does not pass the vertical line test, which makes this not a function or a one-to-one function, just a relation. Alright, so now we're going to go over how to find the inverse of an equation. So, first step, let's say we have f of x equals x minus 4. So first up, we need to rewrite f as x as y. So it's just a linear equation, y equals x minus 4. And now we're going to swap x and y. So x equals y minus 4. And after that, it's just like a regular equation. We need to solve for y. So we add 4 to both sides, and boom, y equals x plus 4. And to find if this is a function, we can just test values again. So if x is 1, y is 5. And if x is 2, y is 6. If x is negative 2, y is 2. And lastly, let's say x is negative 4, then y is 0. So this, just based off of these 4 points, we can safely assume that this is a relation, a function, and a one-to-one function, because it fits all the categories and passes all the tests. And we can actually graph this to make sure that it is exactly that. There we go. It is, in fact, a relation, function, and a one-to-one function because it is a linear equation. Thank you for listening to my lesson or tutorial of identifying relations, functions, and one-to-one functions. I really hope this helps and it taught you just the basics of identifying relation functions and one-to-one functions through mapping, graphing, equations, and finding the inverse. Although I didn't go over complicated problems. Here, those are just the basics of finding relations, functions, and one-to-one functions. Thank you for watching.